Welcome to our video on measures of dispersion. Today, we'll cover the following topics. What are measures of dispersion? Why are measures of dispersion important? Applications in data science, range, variance, standard deviation, interquartile range, IQR. Let's dive in. What are measures of dispersion? Measures of dispersion describe how spread out the data points are in a dataset. They provide insights into the variability and consistency of the data, helping us understand how much individual data points differ from the average. They include range, variance, standard deviation, and interquartile range, IQR. Why are measures of dispersion important? Measures of dispersion are crucial because they reveal how spread out data points are around the average. This insight helps us understand data variability, identify outliers, and assess the consistency of data. In data science, they guide us in improving model accuracy, feature selection, and making informed decisions by highlighting the reliability and quality of our data. Applications in data science, data cleaning, identifying outliers or anomalies by analyzing data spread, feature engineering, understanding the variability in features to improve model performance, predictive modeling, assessing how spread affects model accuracy and making necessary adjustments, risk assessment, evaluating financial or operational risks by analyzing variability in key metrics. Let's start with the range. Simple measure that shows how spread out the values are in a dataset. It is calculated by finding the difference between the highest and lowest values. Let's look at how to calculate it. First, identify the maximum value in your dataset. For our example dataset, 5, 8, 12, 7, 15, the maximum value is 15. This is the largest number in the set. Next, find the minimum value in the dataset. In our example, the minimum value is 5, which is the smallest number in the dataset. Now, calculate the range by subtracting the minimum value from the maximum value. In our example, subtracting 5 from 15 gives us a range of 10. This tells us how spread out the values are. In summary, the range is the difference between the highest and lowest values in a dataset. By following these steps, identifying the maximum and minimum values and then calculating their difference, you can easily determine the range. This simple measure gives you a basic idea of how spread out the values are. Welcome to our lesson on variance. Variance is a key statistical measure that tells us how much the values in a dataset deviate from the mean. It helps us understand the spread or dispersion of the data points around the average. Variance is calculated using different formulas depending on whether you have data from a whole population or just a sample. For a population, the variance formula is the sum of squared deviations from the mean, divided by the number of values. For a sample, we divide by 1 less than the number of values to account for sample variability. First, calculate the mean of your dataset. For the dataset, 4, 8, 6, add up all the values and divide by the number of values. In this case, the mean is 6. Next, find the deviation of each value from the mean by subtracting the mean from each value. For our dataset, 4, 8, 6, the deviations are -2, 2, and 0. Square each deviation to eliminate negative values and highlight larger deviations. For our deviations, -2, 2, 0, the squared deviations are 4, 4, and 0. To calculate the variance, sum up all the squared deviations and then divide by the number of values -1. For our example, the sum of squared deviations is 8. With a sample size of 3, the variance is 8 divided by 2, which equals 4. In summary, variance measures how much data points differ from the mean, on average. By calculating the mean, squaring the deviations, and averaging these squared deviations, we obtain the variance. This measure helps us understand the spread of data points around the average. Standard deviation measures how spread out the data points are from the mean. It provides a clear measure of dispersion in the same units as the data, making it easier to interpret. Before we calculate the standard deviation, let's recall the variance value we calculated earlier. For this example, the variance is 4. To find the standard deviation, we take the square root of the variance. Using the variance value of 4, the standard deviation is calculated by taking the square root of 4, which equals 2. So, the standard deviation is 2. The standard deviation of 2 indicates that, on average, the data points are 2 units away from the mean. This helps us understand the spread of the data and its variability. In summary, standard deviation provides a measure of how spread out the data points are from the mean. By taking the square root of the variance, we determine the standard deviation to be 2. This measure helps us better understand the distribution of our data. The interquartile range, or IQR, measures the spread of the middle 50% of the data. It helps us understand where the central portion of the data lies and is less influenced by outliers compared to the range. To understand IQR, we first need to know about quartiles. Q1 is the 25th percentile, Q2 is the median or 50th percentile, and Q3 is the 75th percentile. These quartiles divide the data into 4 equal parts. To calculate the IQR, use the formula, IQR equals 3 minus 1, IQR equals Q3 minus Q1. This formula simply subtracts the first quartile from the third quartile. Let's calculate the IQR with this data set: 5, 7, 8, 12, 15, 18, 22. The first quartile, Q1, is 7 and the third quartile, Q3, is 18. Subtracting Q1 from Q3 gives us, IQR equals 18 minus 7 equals 11, IQR equals 18 minus 7 equals 11. So, the IQR is 11. The IQR of 11 tells us that the middle 50% of the data is spread across 11 units. This measure is useful for understanding the range of the central portion of the data and can help in identifying outliers. In summary, the interquartile range measures the spread of the middle 50% of the data. By determining the first and third quartiles and subtracting them, we calculated the IQR to be 11 in our example. This helps us understand the central spread of our data. Thanks for watching. If you found this video helpful, please like and subscribe for more content on data science and statistics. See you in the next video.